Okay, let's review integers. We're going to start off with addition. Addition of integers. If you have 2 plus 3, 2 and 3 are both positive and you're combining those, you will get 5. We all know that. We can do those with integer symbols. We have 2 positives there and 3 positives there. So you have a total of 5 positives, which would be your answer. You have no 0 pairs to create, so you're done. When you have positive plus a positive, it will always be a positive because you're going right on the number line each time. If you think of a number line, here's 0, 1, 2, 3, 4, 5. The first integer you would hop over 2. The second integer you would hop over 3, ending at positive 5. You hop to the right each time because they're positive. When you have a negative plus a negative plus a negative will always be a negative. Will always be a negative. For example, if we have negative 2 plus negative 3, that will equal negative 5. The reason that is we have 2 negatives here and 3 negatives here. You can't make any 0 pairs, so you're left with negative 5. On a number line, you could make that very simply by saying here 0, 1, 2, 3, 4, 5. We're going to put those in as negatives. And because we are at negative 2 first, we hop left 2 and then left 3, ending at negative 5. So that's 2 ways you can solve integers. However, this is when you combine opposite signed integers. For example, if you have a negative plus a positive, the answer will be the bigger number's sign. You will take the bigger number's sign and then subtract the 2 numbers. For the first 2, when it was a positive plus a positive and a negative plus a negative, you kept the sign and added them. In this case, if we have negative 3 plus positive 2, we could use several ways to solve this. We could put down 3 negatives. We could put down 2 positives. You can see that we can make a 0 pair here and a 0 pair here, leaving our answer to be negative 1. If we did that on a number line, here's our number line. We can quickly write that in by saying the first integer is negative 3. So we're going to start at 0 and go to negative 3. That line represents our negative 3. But the next integer is a positive 2. So we need to go back from where we were, positive 2. Positive 2 means go to the right, and you'll see that you end on negative 1. One of the big problems that students have with integers is when there's subtraction problems. When there's subtraction problems, I need you to remember to always stay, change, change it. Stay, change, change will turn it into an addition problem. For example, if I have negative 3 minus 2 equals, I'm going to stay, change, change. This integer is going to stay the same at negative 3. This symbol for subtraction is going to change to an addition. We're going to make it its inverse. This integer will also change to its inverse or opposite, which is negative 2. Remember, in the original problem, that is the operation. Negative 3 is the first integer and positive 2 is the second integer. Because there's no symbol, it means it's positive. Now you have an addition problem, remembering that 2 negatives equal a negative and you can combine them and get 5. You could do with that with integer chips. Seeing that there's no 0 pairs, you'll still get negative 5. Or you could do it with a number line. This is 3 methods that you guys could solve integers. The first integer was negative 3, so we're going to go to negative 3. The second integer we've got to combine with is negative again, so we're going to end up at negative 5. So every time you do it, there's 3 methods. So whenever you have a subtraction problem, the most important thing to do is to convert it to an addition problem by state change change. Once you state change change, it turns into an addition problem, then it's easy to do. So this one on our own. We have -3 plus -4. This one's an addition, so we're combining negatives. I would advise you to write 3 negatives here, 4 negatives there. Realizing you can't make a zero pair, your answer, Blake, will be what?
-7.
-7 is correct. Then I could ask you to write another problem down. Let's try -3 minus -4. Remember, you must state change this. Jack, would you state change this, please? The first term is -3, it stays.
Plus +4.
We're changing the subtraction to a positive, and we're changing the last term from a negative to a positive. Here was our stay, here was our change, here was our change. Now we have -3 plus 4. 3 negatives, 4 positives, 0 pairs. Answer, +1. Let's try another one. Let's try 4 minus -7. Again, because it's a subtraction problem, you want to state change it. So our first integer will stay as a 4. Our subtraction symbol will turn to an addition. And our last term, that -7, is going to turn to a +7. 7 plus 4 equals 11. Or you could have used algebra tiles, having 4 positives here, 7 positives here, added them all up, and you would get +11. With integers, multiplication is our next rule. And these rules are quite simple, and you use the same ones for division. Okay? This is just a good refresher. You guys need to remember these when you're doing algebra. Your algebra is wrong because of the inappropriateness on your integers. So you got to get these right. So if we have a positive times a positive, it will equal a positive. That's no different than saying 2 times 3 equals 6. So that's our first scenario. The second scenario would be if we have a negative times a negative. A negative times a negative is also going to be a positive. For example, -2 times -3 will equal +6. Good note taking, guys. Thank you. Our last situation we could have for these would be a negative and a positive. A negative times a positive, or a positive times a negative, whichever way you go, will always equal a negative. So -2 times +3 equals -6, or +2 times -3 equals -6. The only time in multiplication you get a negative is when the signs are opposites. The rest of the time it's always positive. Same sign positive, opposite signs negative. I always think of Twilight. Werewolves and vampires. Opposites don't match. It's a negative situation. They were always fighting. Fighting is negative. So that situation with multiplication, you can carry division, because division is just the inverse of multiplication. You just need to check it. So if you have a positive dividend and you're dividing it by a positive divisor, a positive times something will equal that positive. Well, a positive times a positive will equal a positive. Same situation goes if you have a positive as the divisor and the dividend is a negative. A positive times a negative makes a negative. If for some reason you have a negative divided by a negative, this would be a positive because opposite signs will always equal the negative. And the last situation we could have is we could have a negative and a positive here and another negative up there because we have a negative times a negative being a positive. So that is a quick review on integers. I hope it helps you. Please watch this many, many times and I'll see you in class.